Welcome to a deep dive into Eliza AI agent packages.
Mm.
It's kind of like having a superpowered personal assistant, but way cooler. We've got a ton of research and notes on this, and we're here to break it all down.
We'll be talking about AI agents that can manage your social media, analyze financial markets, even try their hand at meme coin trading.
Exactly. It's pretty wild. So Eliza is this framework for building these agents, and it uses a really cool modular design with packages. It's like building with Legos. You just snap different pieces together to make your agent do what you want.
That's a great analogy. Each package has a specific role to play, like specialized tools in a toolbox.
Okay, so let's unpack this toolbox. What are the core components of Eliza?
Well, at the heart of it all is the @i16 score package. Think of it as the engine handling memory, messages, and all the actions it can take.
Okay, got it. The core, the brains of the operation. What else?
Then there's the @i16's agent package. It's like the conductor, orchestrating how your agent interacts with the world. It loads the agent's personality, connects to different platforms, and basically runs the show.
So at I16 score is the brain, and an I66 agent is the one making sure the brain knows what to do.
Precisely. Now, to make sure your agent can remember things and store information, we have @i16's adapters. These connect to databases like PostgreSQL and SQL.
Databases. Okay, so it's like the agent's long-term memory.
Exactly. And your agent needs to be able to communicate, right? That's where @i16's clients come in. Think of them as the agent's voice, allowing it to chat on Discord, tweet on Twitter, or send messages on Telegram, all sorts of things.
So if I wanted my Eliza agent to be a social media guru, I'd need those client packages.
Absolutely. And then we have the @i16's plugins. These are the really fun part. They add those extra special skills and features that make your agent truly unique.
Plugins, that's where things get really interesting. I bet there are a ton of different plugins to choose from.
There are. We'll dive into some fascinating examples later, but for now, just know that plugins are the key to customizing your agent and giving it superpowers.
Okay, so we've got core, agent, adapters, clients, and plugins. It's starting to make sense. But how do we actually go about building a custom agent package? Where do we begin?
Well, think of it like this. We're going to guide you on how to assemble your own AI agent toolkit, piece by piece, using these Eliza packages.
Okay, I like the sound of that. Lead the way.
First things first, you always start with the core package. At II16 Core, that's your foundation, the starting point for any Eliza agent.
Got it. Core package, check. What's next?
Next, you need to decide how you want to store your agent's data. That means choosing the right database adapter from II16's adapters. PostgreSQL is great for robust setups, while Squella it might be better for something simpler. It really depends on what you're building.
So even at the database level, there are choices to make. Interesting.
Yep. Once you have your database sorted out, you'll want to connect your agent to the platforms where it'll operate. This is where the client packages come in. Want your agent to tweet? Grab the Twitter client. Need it to hang out on Discord? There's a client for that too.
So we're basically giving our agent a way to communicate with the outside world.
Exactly. And finally, you'll want to give your agent some unique abilities and superpowers. That's where plugins come in.
Okay, let's talk plugins. I'm really curious about this. It's like now we get to design the personality and skill set of our AI agent. Right?
You got it. Plugins let you add all sorts of capabilities, from image generation to blockchain interaction.
So if I wanted my agent to be like a meme coin trading whiz, I'd need some specific plugins for that.
Exactly. There's actually a Solana plugin that lets your agent interact with the Solana blockchain, perfect for analyzing those meme coins.
Now we're talking. But wouldn't we also need some way for the agent to actually execute trades, like in a simulation?
You're thinking ahead. And yes, for something like that, you'd likely need a custom plugin.
Custom plugin, huh? That sounds a bit more advanced.
It's not as daunting as it sounds. We'll get into the details of how to create custom plugins later on. But just know it's totally possible to create a plugin that does exactly what you need it to do, like executing those meme coin trades. But in a simulated environment, of course.
Okay, custom plugins are on my to-learn list. But first, let's dive deeper into those pre-built plugins you mentioned. What kind of cool stuff is already out there?
Well, let's start with the Coinbase suite. These plugins give your agent some serious financial capabilities.
Coinbase suite. Sounds intriguing.
This suite includes plugins like Coinbase Commerce, which lets your agent create payment charges. Imagine an agent that can handle crypto payments for you.
That's wild. What else is in this suite?
There's also Coinbase Mass Payments, which can streamline crypto distributions. Imagine an agent that handles payroll for your company, or even automatically pays content creators based on their engagement.
Okay, now you're talking my language. What about managing digital assets like NFTs? Does Eliza have anything for that?
You bet. The Coinbase Token Contract plugin lets you deploy and interact with token contracts, like ERC20, ERC721, and ERC11155.
Hmm.
Basically, your agent can manage digital assets, create NFTs, even build entire tokenized economies.
Wow, that's next level stuff. But hold on a second. If we're talking about agents handling financial transactions, what about security? I mean, crypto is a big target for hackers, right?
You're right to be concerned about security, and Eliza has got you covered. There's a plugin called TE, which stands for Trusted Execution Environment.
What's so special about that?
Well, it leverages a secure hardware environment to protect sensitive operations like generating and storing your crypto keys, like having a digital vault built right into your computer.
Okay, that definitely sounds more secure. So the TE plugin helps keep those crypto keys safe from prying eyes.
Exactly. And it also supports both Solana and Ethereum key derivation, so you have flexibility in choosing which blockchain ecosystem to work with.
Flexibility is always good. So we've got security covered. What about real-time data? Say I want my agent to be notified when a certain crypto asset hits a specific price.
For that, you'd want to check out the Webhook plugin. It connects with Coinbase's system, allowing your agent to listen for specific events, like price changes or transfers.
So the Webhook plugin gives my agent the ability to react to things happening in real time.
Precisely. It's super useful for building agents that need to monitor market trends, track portfolio performance, or make quick decisions based on real-time data.
Wow, the possibilities are really starting to open up here.
And we've only just scratched the surface. There's a whole world of Eliza plugins out there, both pre-built and custom, waiting to be explored.
Okay, so now I'm really itching to get my hands dirty and start building. But before we jump into that, are there any general tips or best practices we should keep in mind when working with Eliza packages?
Absolutely. One of the most important things is to make sure you're handling errors properly. You want your agents to be robust and reliable, so they need to be able to gracefully handle any hiccups they might encounter.
Right, so we don't want our agents crashing and burning at the first sign of trouble.
Exactly. Eliza's API documentation is a fantastic resource for understanding how to handle errors effectively. It's like a detailed guidebook.
Okay, API documentation, check. Anything else we should be aware of?
Another common issue to watch out for is conflicts when registering services. Remember how Eliza uses a service architecture?
Yeah, you mentioned that earlier.
Well, if two packages try to register services with the same name, you'll run into a conflict. It's like two people trying to book the same hotel room.
Oh, I see. So we need to make sure our services have unique names to avoid any clashes.
Precisely. Eliza usually throws an error message if there's a conflict, so it's easy to spot and fix.
Okay, error handling and service registration. Got it. I'm feeling more confident now. So are we ready to roll up our sleeves and start building our first custom Eliza package?
Let's do it. We'll walk you through the process step by step, starting with understanding the basic structure of an Eliza package.
Okay, I'm all ears. Lead the way.
An Eliza package is like a self-contained module with a specific purpose. It's kind of like a mini program within the larger Eliza ecosystem.
Okay, so it's like a building block that we can use to create larger, more complex agents.
Exactly. And every Eliza package has a few key elements that make it work.
Okay, let's break those down. What's the first essential ingredient in our Eliza package recipe?
First up, you have the package manifest. It's typically a file called package.json. Think of this as the blueprint for your package. It tells the system what your package is called, who created it, what version it is, and most importantly, what other packages it depends on.
So it's like the package's ID card and its list of ingredients.
Perfect analogy. Next, you have the entry point. This is the file that gets executed when your package is loaded by Eliza. Like the main door to your house, it's how Eliza enters and interacts with your package.
Got it. The entry point is where the action starts.
Then you have the core logic of your package. This is where you actually write the code that defines what your package does, like the heart and soul of your package, where you bring your ideas to life.
So if we were building that meme coin trading agent, the core logic would be where we write the code to analyze Twitter sentiment, interact with the Solana blockchain, and execute those simulated trades.
Exactly. And finally, you have the dependencies. These are other Eliza packages or external libraries that your package relies on to do its job.
So if our meme coin trader needs to interact with Twitter, we'd include the Twitter client package as a dependency.
You got it. It's all about identifying what external resources your package needs and listing them in the package.json file. Then the package manager takes care of fetching and installing those dependencies for you.
Okay, so we have our blueprint, our entry point, our core logic, and our dependencies. It's starting to feel like a real software project now, but that's also what's so cool about Eliza. It gives us this framework to build sophisticated agents by leveraging existing tools and libraries.
Exactly. It's like having a giant Lego set where you can mix and match pieces to create something truly unique.
Now let's talk about the code itself. I'm assuming writing code for an Eliza package isn't exactly like writing any old JavaScript code.
Mhm.
Are there specific things we need to keep in mind?
You're absolutely right. There are some ELIZA-specific principles and best practices that will make your life a lot easier and ensure your package works seamlessly within the framework.
Okay, I'm ready to absorb some wisdom. What are these key principles?
The first and most important principle is to adhere to the ELIZA plugin interface. This interface defines a specific structure for how plugins should be written, and it's essential for making sure your package can be loaded and used by ELIZA correctly.
So it's like a set of rules that guarantees our package can talk to Eliza and understand its commands.
Exactly. It's like speaking the same language, so to speak. If you don't follow the ELIZA plugin interface, your package might not work as expected, or it might not work at all.
Okay, following the rules, got it. What's the next principle?
The next crucial principle is proper state management. ELIZA agents maintain a state, which is basically their current knowledge and context within a conversation or task.
So if our meme coin trading agent is analyzing Twitter sentiment, its state might include information about which meme coins it's currently tracking and what the latest sentiment scores are for each.
Exactly. And when your package performs actions, it needs to update the agent's state accordingly. This ensures that the agent's knowledge is always up to date and that its actions have the intended consequences.
Okay, state management check. It's like making sure the agent is always aware of what's going on and updating its memory accordingly.
Precisely. Now, another key principle for building robust and maintainable ELIZA packages is to leverage ELIZA's service architecture.
Service architecture. That sounds familiar. Didn't you mention something about that earlier?
Yes, I did. Remember how I said that two packages can't register services with the same name? That's because ELIZA uses a service-based approach to organizing functionality.
Okay, I'm starting to remember now. So instead of just writing a bunch of isolated functions or blocks of code, we should think in terms of services that can be reused and shared across different parts of Eliza.
Exactly. A service is like a self-contained unit of functionality that can be accessed and used by other components within ELIZA. For example, if your package needs to interact with an external API, you might create an API service that handles all the communication logic.
That way, other packages or even core Eliza components could use that API service without having to reinvent the wheel.
Precisely. It's a great way to promote modularity, reusability, and a more organized code base.
Okay, so we've got our three key principles: following the Eliza plugin interface, managing state properly, and leveraging the service architecture. I'm feeling like a more enlightened Eliza developer already. But let's be realistic here. Coding is rarely a smooth sailing experience. What are some common challenges developers might encounter when building Eliza packages? And how can we navigate those choppy waters?
Well, one of the most common challenges is dealing with plugin loading errors. These can pop up for various reasons, like incorrect file paths, typos in your code, or missing dependencies.
Oh, I can definitely see how those could cause some major headaches. How do we even begin to troubleshoot those plugin loading errors?
The first step is to carefully read those error messages that ELIZA throws at you. They often provide helpful clues, like pointing to the specific file and line number where the problem is occurring.
So it's like Eliza's giving us a treasure map to find the buried treasure, which in this case is the bug in our code.
Exactly. And don't underestimate the power of console logging. Strategically placing console.log statements in your code can help you track the flow of execution and figure out where things are going wrong.
It's like having a behind-the-scenes look at how your code is running, so you can spot any suspicious activity.
Precisely. Now, another challenge you might encounter is service registration conflicts. Remember, if two packages try to register services with the same name, ELIZA won't be too happy.
Right, it's like that double booking situation we talked about earlier.
Exactly. To avoid this, make sure each service in your package has a unique identifier. It's like giving each service a unique name tag so that ELIZA can easily distinguish between them.
Okay, unique service names, got it. Is there anything else we should be prepared for?
A general tip is to always refer to ELIZA's API documentation. It's a treasure trove of information about the framework, including how to handle errors, register services, and build plugins effectively.
So the API documentation is like our Eliza encyclopedia.
Yep.
Got it.
Exactly. It's your go-to resource for all things Eliza. It's your go-to resource for all things Eliza.
Okay, we've written our code, we've tested it, squashed those pesky bugs. What happens next? How do we actually package up our Eliza creation and share it with the world?
That's a great question. Packaging an ELIZA package is all about bundling up your code, its dependencies, and some metadata into a neat little package that others can easily install and use.
So like taking all the pieces of our amazing AI agent and putting them into a box with a nice label so that someone else can open it up and easily put it all together.
Exactly. And the tool that helps us do this is called a package manager. There are a few popular ones out there like NTM or Yarn. They make the process of organizing, managing, and distributing code incredibly easy.
Okay, package manager, check. Walk me through the steps of how we'd actually use a package manager to package up our Eliza creation.
The first step is to initialize a new package directory and create a file called package.json. This file is like the instruction manual for your package. It tells the package manager what your package is all about, who created it, what version it is, and what other packages it needs to work properly.
So like giving our package a unique identity and a list of ingredients.
Precisely. Next, you'll need to organize your code files within the package directory. A common convention is to create a folder called SRC where you put all your source code.
So it's like creating a dedicated workspace for all the building blocks of our Eliza package.
Yes, and within that SRC folder, you can further organize your code into subfolders or modules, just like you would in any other software project.
Organization is key.
Got it. Now, in your package.json file, you'll need to specify the entry point of your package. This tells the package manager which file to run when someone installs and uses your package.
So it's like telling the package manager, hey, start the show by running this file right here.
Exactly. And speaking of starting the show, remember those dependencies we talked about. You'll need to list all the external packages or libraries that your package needs to work properly in the dependencies section of your package.json file.
Right, it's like listing all the ingredients our Eliza package recipe needs.
Precisely. Once you've listed all the dependencies, you can use the package manager to install them. The package manager will fetch all the necessary files from the internet and put them in a special folder within your package directory.
It's like the package manager is our personal shopper, going out and getting all the ingredients we need.
Love the analogy. And finally, once everything is organized and all the dependencies are installed, you can use the package manager to create a distributable package file.
Distributable package file, what's that?
It's basically a compressed file, like a .zip file, that contains all your package's code, its dependencies, and that all-important package.json file.
So it's like packaging everything up into a neat little box that we can easily ship to others.
Exactly. This package file is what you'll then publish to a package registry, like the NPM registry, making it available for others to download and use in their own ELIZA projects.
And that's how our custom Eliza package goes from a bunch of code files on our computer to a reusable component that can empower other developers to build amazing AI agents.
Precisely. It's an exciting journey that combines creativity, coding, and a bit of packaging know-how to expand the possibilities of the ELIZA ecosystem.
I can't wait to get started. But hold on a second. Before we release our package into the wild, we need to make sure it actually works right. Testing is crucial.
You are absolutely right. Testing is an essential part of software development, especially when it comes to something as complex as an ELIZA package.
Okay, so how do we go about testing our Eliza package thoroughly? What are the best practices?
Well, there are several levels of testing that we can apply to our ELIZA package: unit testing, integration testing, and end-to-end testing. Each level focuses on a different aspect of the package and helps ensure that it's robust, reliable, and does exactly what it's supposed to do.
Okay, let's break those down. What is unit testing all about?
Unit testing is like taking your package apart and testing each individual component in isolation.
So if we had a function in our meme coin trading agent that calculates the sentiment score of a tweet, we'd write unit tests to make sure that function works correctly on its own without worrying about the rest of the agent's code.
Exactly. It's about making sure that each building block of your package is solid and reliable.
Got it. So unit testing is for individual components. What about integration testing?
Integration testing takes a step back and looks at how different parts of your package work together.
So if our meme coin trading agent has a module for analyzing Twitter sentiment and another module for making trade decisions, integration testing would make sure that those two modules can communicate and work together without any hiccups.
Precisely. It's about making sure that the different pieces of your package fit together seamlessly.
Okay, unit testing for individual parts, integration testing for how those parts work together. What about end-to-end testing? What does that involve?
End-to-end testing is the most comprehensive level of testing. It involves running your ELIZA package within the context of the entire ELIZA system, simulating real-world scenarios and making sure that your package behaves as expected from start to finish.
So for our meme coin trader, this might involve feeding it mock Twitter data and seeing if it makes the correct trading decisions based on the simulated market conditions.
Exactly. End-to-end testing is like the final dress rehearsal. It gives you confidence that your package is ready.
This multi-layered testing approach seems incredibly thorough. Are there any tools or frameworks that can help us write and run these tests more effectively?
Absolutely. The JavaScript ecosystem is full of fantastic testing tools. One popular choice is Jest, a testing framework developed by Facebook. It's known for its ease of use, powerful features, and seamless integration with code coverage tools.
Code coverage tools, what are those?
Code coverage tools basically tell you how much of your code is actually being exercised by your tests. It's like a report card that shows you which parts of your code are being put through their paces and which parts might be hiding some potential bugs.
Okay, code coverage.check. So Jest provides the framework for writing tests, and code coverage tools tell us how thorough our tests are. What about actually writing the tests themselves? Any tips or strategies there?
One key strategy is to write tests that are focused and specific. Each test should target a particular piece of functionality, making it easier to pinpoint the source of any issues.
So instead of writing one giant test that tries to cover everything, it's better to break it down into smaller, more targeted tests.
Exactly. Think of it like laser-focused testing. Each test should have a clear objective and should only test one thing at a time.
Got it. Focused and specific testing. Any other best practices to keep in mind?
Another important best practice is to make your tests independent of each other. This means that the outcome of one test should not affect the outcome of another.
Right, so we don't want a domino effect where a failure in one test causes a cascade of failures in other tests.
Exactly. Independent tests give you a clear picture of what's working and what's not. They help you isolate issues and pinpoint the root cause of any bugs.
Okay, independent testing check. I'm starting to feel like a testing pro already.
That's the spirit. Remember, thorough testing is an investment in the quality and reliability of your ELIZA package. It might seem tedious at times, but it will save you headaches in the long run.
Totally agree. It's better to catch those bugs early on than to have them come back and bite us later.
Exactly. Now, once you've tested your ELIZA package thoroughly and you're confident that it's working as expected, it's time to share your creation with the world.
Okay, let's do it. How do we unleash our ELIZA package onto the unsuspecting public?
The process of releasing an ELIZA package involves publishing it to a package registry. The most common one for JavaScript packages, including ELIZA packages, is the NPM registry. It's like a giant library of code packages where developers can find and download reusable components.
So it's like putting our ELIZA package on display for the whole world to see and use.
Exactly. To publish to the NPM registry, you'll need an NPM account, which you can easily create on their website. Once you have an account, you can use the npm publish command from your package directory to upload your package to the registry.
So it's like hitting the publish button on our masterpiece.
Precisely. But before you hit that publish button, there are a few things you need to double check.
Okay, what are the pre-flight checks before launching our ELIZA package into orbit?
First, make sure you've properly configured your package's package.json file. This file contains all the essential information about your package: its name, version, description, author, license, and dependencies.
Right, it's like giving our package a passport and a detailed resume.
Exactly. The package name is particularly important. Make sure it's descriptive, unique, and doesn't clash with any existing packages on the registry.
So if we were releasing our meme coin trading agent as a package, we might call it something like ELIZA Meme Coin Trader.
That's a perfect example. Clear, concise, and immediately tells users what the package is all about.
Okay, package naming, check. What about versioning? I've heard that's important for keeping track of updates and changes to a package over time.
You're absolutely right. Versioning is crucial. And ELIZA packages typically follow the semantic versioning scheme, also known as SEMVer.
SEMVer, I've heard of that. It's a system that uses a three-part version number, like 1.2.3, where each part represents a different level of change, right?
Exactly. The first number represents the major version, which you increase when you make big breaking changes. The The second number is the minor version, which you bump up when you add new features but keep things backwards compatible. And the third number is the patch version, which you increment for bug fixes and other small improvements.
So it's a way to communicate to users what kind of changes they can expect.
Precisely. Clear versioning makes it much easier for developers to manage dependencies and ensure that their Eliza projects stay compatible over time.
Okay, versioning, check. Anything else we need to do before hitting that npm publish button?
One last thing. Make sure you have a re-IAB file in your package directory. This file serves as the documentation for your package, explaining what it does, how to install it, and how to use it.
So it's like the instruction manual for our Eliza package.
Exactly. A well-written re-IDA file is essential for making your package user-friendly. It should be clear, concise, and include code examples to show users how to use the various features of your package.
Okay, I'm feeling pretty confident now. We've written our code, tested it, packaged it up, and even written a beautiful re-ADME file. Time to launch this baby.
You got it. Hit that npm publish button, and your Eliza package will be out there for the world to use. You've officially contributed to the amazing world of Eliza.
That's an incredible feeling. But wait a second. Releasing a package isn't a one-time thing, right? What about maintenance and updates?
You're right. Releasing a package is just the beginning of the journey. To keep your package relevant and valuable, you need to be proactive about maintenance, bug fixes, and updates.
So it's like tending a garden. We need to keep watering and nurturing our Eliza package to help it grow.
Exactly. One of the most important aspects of package maintenance is communication. Establish a clear channel where users can report issues, ask questions, or suggest new features.
So we need to be open to feedback and make sure we're listening to our users.
Precisely. You can use a forum, a GitHub issue tracker, or even social media to create a space where you can interact with your users and get valuable feedback.
Okay, communication is key. What about those inevitable bug reports? How should we approach those?
Bug reports are valuable pieces of information. They tell you where your package might be falling short or behaving unexpectedly. Embrace them as opportunities to improve your code and make your package even better.
So instead of seeing bug reports as criticisms, we should view them as helpful pointers.
Exactly. When you receive a bug report, the first step is to try and reproduce the issue yourself. Once you can consistently reproduce the bug, you can start investigating its cause and developing a fix.
It's like being a detective, tracking down clues.
Exactly. And once you've developed a fix, make sure to test it thoroughly. Ensure that it solves the problem without introducing new ones.
Okay, bug fixes, check. What about updates? How often should we aim to release new versions of our Eliza package?
The frequency of updates depends on several factors. The complexity of your package, the number of bug reports or feature requests you receive, and the pace of development within the Eliza ecosystem itself.
So there's no magic number. It's about finding a rhythm.
Exactly. Some packages might have monthly updates, while others might have updates every few weeks or even more frequently.
Okay. So we've talked about communication, bug fixes, and updates. Is there anything else we should keep in mind when it comes to maintaining our Eliza package?
One crucial aspect of package maintenance is ensuring that your package stays compatible with new releases of the Eliza framework itself. Eliza is constantly evolving, and you don't want your package to get left behind.
Right. We need to make sure our Eliza package can keep up with the times.
Exactly. As new versions of Eliza are released, they might introduce changes that could affect how your package works. You might need to update dependencies, modify your code, or even add new features to keep your package in sync.
So it's an ongoing process of adaptation and evolution.
Precisely. It's about staying engaged with the Eliza community and making sure your package remains a valuable part of the ecosystem.
Okay, so we've covered a lot of ground here. Building, testing, packaging, and even maintaining Eliza packages. It's been an incredibly insightful journey.
I'm glad you're finding it valuable. But we're not quite done yet. There's one more aspect of the Eliza world that we need to explore. The community itself.
The Eliza community. Tell me more.
Well, Eliza isn't just a framework. It's a community of passionate developers, researchers, and enthusiasts who are all working together to push the boundaries of AI agent technology.
That sounds amazing. So it's like a collaborative space where people can share ideas, learn from each other, and build amazing things together.
Exactly. And as a package developer, you have the opportunity to be an active part of this community.
Okay, I'm intrigued. How can we get involved and contribute to the Eliza community?
Well, one way is to simply use Eliza and share your experiences. Write blog posts, create tutorials, give talks at conferences, spread the word about the awesome things you're building with Eliza.
So it's about being an evangelist for Eliza.
Precisely. And if you're feeling really ambitious, you can even contribute code directly to the Eliza project itself.
Whoa, contributing code to Eliza. That
Yeah.
sounds pretty hardcore. How do we even get started with that?
Eliza is an open source project, which means that its code is publicly available on platforms like GitHub.
GitHub, the code repository where developers hang out and collaborate on projects.
Exactly. If you're familiar with Git and GitHub, you can fork the Eliza repository, make changes to the code, and submit a pull request. If the Eliza developers like your changes, they might merge them into the main project.
So it's like submitting our own ideas and improvements to the Eliza Brain Trust.
Precisely. Contributing code to Eliza is a fantastic way to give back to the community, learn from experienced developers, and have a direct impact on the future of the framework.
Wow, that's incredibly empowering. I never thought I'd be able to contribute to a cutting-edge AI project like Eliza.
You absolutely can. The Eliza community welcomes contributions from developers of all skill levels. Whether you're a seasoned veteran or just starting out, there's a place for you in the Eliza community.
That's really inspiring. So contributing to Eliza isn't just about writing code. It's about being an active member of this vibrant community and helping to shape the future of AI agent technology.
Exactly. It's about collaboration, knowledge sharing, and a collective passion for pushing the boundaries of what's possible with AI.
I love that. It makes me even more excited to dive into the world of Eliza and see what I can create.
That's the spirit. And remember, the Eliza community is always there to support you along the way. Don't be afraid to ask questions, share your ideas, and learn from others.
Okay, so we've covered building, testing, packaging, maintaining, and even contributing to the Eliza ecosystem. It's been an incredible journey. But before we wrap things up, I'd love to step back for a moment and consider the broader implications of this technology. AI agents are becoming increasingly sophisticated. What are some of the potential impacts we might see as these agents become more integrated into our lives?
That's a great question. The rise of AI agents has the potential to reshape many aspects of our lives, from the way we work to the way we interact with the world around us.
Okay, I'm ready for some mind-blowing predictions. What are some of the areas where you see AI agents having the biggest impact?
Well, one area where we're already seeing significant changes is in the workplace. AI agents are automating tasks, streamlining processes, and even taking on roles that were once considered exclusively human.
So we're talking about AI agents as coworkers, assistants, and even decision makers.
Exactly. AI agents can analyze data, generate reports, schedule meetings, manage emails, and even provide personalized recommendations and insights. They can free up human workers from tedious and repetitive tasks, allowing them to focus on more creative and strategic work.
That sounds like a win-win situation. Humans get to do more fulfilling work, and AI agents handle the tasks that no one really enjoys doing anyway.
Precisely. And as AI agents become more sophisticated, they'll be able to take on even more complex roles, potentially leading to increased productivity, efficiency, and innovation in the workplace.
Okay, so AI agents are transforming the way we work. What about other areas of our lives? How might AI agents change the way we interact with the world around us?
Well, imagine having a personalized AI agent that acts as your digital companion, assistant, and advisor, all rolled into one.
It's like having a super smart sidekick who's always there to help you out.
Exactly. Your AI agent could help you manage your schedule, filter information overload, make informed decisions, and even learn and evolve alongside you.
Okay, that's starting to sound like something out of a science fiction movie,
Yeah.
but also incredibly cool.
Right. And think about the possibilities for personalized education, healthcare, and entertainment. AI agents could tailor learning experiences to individual needs, provide personalized health recommendations, even create customized entertainment experiences based on your preferences.
It's like having a world of customized experiences at our fingertips. But with all this talk about AI agents taking on more responsibilities, what about the role of humans? Are we destined to be replaced by our AI overlords?
I don't think it's about replacement, but rather about collaboration. AI agents are tools that can augment our capabilities and help us achieve more than we could on our own.
So it's about humans and AI working together, each leveraging their strengths.
Exactly. Humans bring creativity, empathy, and critical thinking to the table, while AI agents offer speed, efficiency, and data processing power.
It's like a symbiotic relationship where each partner benefits from the other's unique abilities.
Precisely. And as AI agents become more integrated into our lives, it's important to remember that we have the power to shape their development. ensure that they align with our values and goals.
So it's not about letting AI control us, but about using AI as a tool to empower us and create a better future.
Exactly. The future of AI is not predetermined. It's something that we can actively shape through our choices, our actions, and our commitment to using technology for good.
That's incredibly empowering. It makes me excited to be a part of this technological revolution, to see what we can achieve, humans and AI alike.
Me too. And remember, the world of Eliza is just one small part of this vast and ever-evolving AI landscape. There are countless other projects, initiatives, and communities out there that are pushing the boundaries of AI in all sorts of amazing ways.
So it's like an invitation to explore, to learn, to experiment, and to never stop being curious about the possibilities of technology.
Exactly. The future of AI is bright, and it's up to all of us to shape it in a way that benefits humanity. Create a world where everyone can thrive.
That's a perfect note to end on. This deep dive into Eliza has been an eye-opening experience. We've explored the technical intricacies of building AI agents, the power and flexibility of the Eliza framework, the importance of community, and even the broader societal and ethical implications of AI.
It's been a pleasure to navigate this fascinating world with you. I'm excited to see what incredible creations will emerge from the Eliza community in the years to come.
To our listeners, we encourage you to explore the world of Eliza, experiment with its packages and plugins, and join the vibrant community.
Remember, the power to create intelligent agents is at your fingertips. So go out there, build something amazing, and let's see what the future holds.
And on that inspiring note, we'll wrap up this deep dive into Eliza AI agent packages. We hope you've enjoyed the journey, and we can't wait to see what you create.
Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible with AI.
Thanks for joining us on this deep dive into Eliza AI agent packages. We hope you've learned something new and are excited to explore the world of AI agents.
Until next time, keep learning, keep exploring, and keep pushing the boundaries of what's possible with technology.
And most importantly, have fun. This is a journey of discovery and creation, so enjoy the ride.
That's the perfect way to end this deep dive. We'll see you next time for another exciting exploration of the world of technology.
Until then, stay curious, stay creative, and stay connected.
Goodbye.